Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. And this is the last of the videos for the revision pack, um, unit 7.4. Once I finish with those, inshallah, I'll be posting another video that will include some conceptual questions and some workout questions for the exam, and then I will compile it all together in one mega compilation revision video. Okay, so let's get on with it. Question 1, we're talking about collisions. Question 1 says, and of course, as always, if you are finding these difficult, if you want more explanation, go back to the original video that explains it. So the original video is an hour long, and it explains things. This is not an explanation video. This is one where we just solve problems. Okay. Thank you very much. Let's get on with it. So a 0.1 kilogram cart moves with a speed of, here's a cart. And it moves with a speed of, the mass of it is 0.1 kilograms, so like a toy cart, and the speed is 0.66. Oh, I'm not going to write it up there because you don't get to see up there. So velocity equals 0.66 meters per second. Okay. On a frictionless air track, so we ignore friction, collides with a stationary cart of mass. So this one has a mass of 0.2 kg. Oh, maybe I should draw it slightly bigger because it is heavier. 0.2 kg. If the two carts stick together after the collision, what is the speed of the two carts? So we're assuming this happened. So this here stuck to the three-wheeled cart. And this is what happened. So they both stuck together, and now they are both moving together at a certain velocity. We know their mass, but we don't know what their velocity is. Their mass is 0.3. Now somebody's asking me, how do you know that? 0.2 plus 0.1. You just add it together, so now it's 0.3. And what is going to be the speed afterwards? Well, in order to calculate the speed afterwards, I need to know the momentum before for both. I need to know the momentum for this and this. This one's not moving. This one has a velocity of 0. So therefore, the momentum for this is 0, right? So the only thing is the momentum for this. 0.1 times 0.66. It's going to be 0.066. Okay? So that is the momentum before for everything, for both carts. The momentum for this is 0.066. The momentum for this is 0. So both momentum combined before equals 0.066. Momentum after, guess what? Momentum before equals momentum after. So it is also 0.066. Can I work out the velocity now? Of course. Velocity equals, come on, P over M. Because the formula is P equals mv, and so velocity is equal to P over M. So 0.066 divided by 0.3, and that equals 0.22 meters per second. Makes sense. So this was moving quite fast, and then it hit this, and it got stuck to it, and now it's moving slow. That is the answer to question 1. I'm going to get rid of it now. Question 2. Question 2. A 25,000 kilogram train car moving at 2.5 meters per second. So here is a train car. Mass equals 25,000 kg. And the velocity is 2.5 meters per second. And it just happens to be colliding with, what does it collide with? And connects to a train car of equal mass moving in the same direction at 1 meters per second. So same mass. I'm just going to write it again just to make it easy for you guys to visualize. And for me too. I actually, like to visualize things. What is the speed of the connected cars? Okay, so the momentum of this before and the momentum of this before is equal to, of course, that we have to add all the momentums before. So this is going to be 25,000 because it's 25,000 times 1. And remember, it's m times v. And this is the same, m times v. So it's 25 times 2.5, which is 62,500. 62,500. So now we have to add both of them together, and that will be 87.5. And then what do we do? And then so that is the total momentum before, P initial, and we know that the P final is the same, 87.5 kg dot meters per second. So what are we trying to find out? We're trying to find the speed of both carts after they stick together. We know the mass of both carts is going to be 50,000 because it's 25 plus 25. So can we work out the velocity? Of course, mister. So easy. 87,500 divided by 50,000. And now we know that the speed is going to be 1.75 meters per second. Easy. Hopefully that wasn't too hard. Right, I'm getting rid of that now. If you feel like I'm going too fast, please pause the video. If you don't understand it, go and watch the original video, please. Question 3. Two 72-kilogram hockey players are skating at 5.45 meters per second, collide and stick together. So I'm assuming they're both going in opposite directions, obviously. So mass equals 72, and this boy here has a mass of 72 as well. Velocity of this one equals 5.45, and the velocity of this one equals negative 5.45, or the magnitude is 5.45 meters per second, obviously. Really good practice to always write the units. I don't usually just leave numbers without units. Right, and then what do we do? If the angle between the initial directions is 90, oops, see, this is why it's really important to read the question, huh? So yes, they are the same mass, but one of them is going... I'm just going to draw the whole thing again. My apologies about that. Hopefully that's a lesson in itself, okay? Make sure you read the question carefully. So I'm just going to draw a bird's eye view. We've got... Oh, this is going to be horrible. Oh God, using this tablet. Bismillah. Go back. That's north. Okay, that'll do. That's north. We've got one going that way, and we've got another person heading him who is heading this way. And this guy is 72 kg, and this guy is 72 kg. And they're both traveling at the same speed, 5.45 meters per second. And this one is also 5.45 meters per second. Now remember, momentum is a vector, so we can actually work out the momentum. Momentum is going to be mass times velocity. So 5.45 multiplied by 72. So that's 392.4. 392.4. And no, I didn't want my face to move. Thank you. You can stay right over here. 392.4. And this one is also the same, 392.4. So what do we do with that? Well, we've got a triangle. Why is it so hard drawing a straight line? Here we go. Perfect. We've got a triangle. This one is 392, and this one is 392. And we are trying to work out the hypotenuse, obviously. So what is this one? No, 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 keep. Excuse me just a second. Here we go. So we are trying to work out the hypotenuse, and of course we know that a squared plus b squared equals c squared. This is c, this is a, this is b. It's a 45 degrees angle. So let's have a look. 392. We've got that, so it's squared. Sorry. A 392 squared plus 392 squared, and the square root of both, so it's about 554. Approximately 554. That's the momentum, kg dot meters per second. We're not done. We've just worked out the momentum. Now we have to work backwards. Momentum equals mass times velocity. So it's going to be 554 is equal to the total mass, which is 72 times 2, which is 144. Okay. And then we have the velocity. So in order to find the velocity, the speed after is going to be 554 divided by 144. So it's about approximately 3.8 meters per second. That's the answer. Hopefully you got something similar to that. It's not asking you for the angle, but if you were to work out the angle, it's at 45 degrees. The reason for that is because they both, it's an equilateral, no, it's a right angle isosceles triangle. Okay, thank you very much. Stay tuned for the next video.